When you have a quadratic equation, if you cannot factor that out, then you can use quadratic formula to find solutions. When the quadratic equation is written by ax squared plus bx plus c equals 0, the solution for that quadratic equation is minus b plus minus square root of b squared minus 4ac over 2a. Here is the terminology. The discriminant is what's written under the square root sign. That's b squared minus 4ac. Depending on that number, the given quadratic equation may have two real solutions, or no solutions, or one real solution. When it has two real solutions, b squared minus 4ac is greater than 0, because in that case, this will produce minus b plus square root of b squared minus 4ac over 2a, and minus b minus square root of b squared minus 4ac over 2a. If the number under the radical sign is less than 0, then it'll become a complex number. So there is no real solution. If b squared minus 4ac vanishes, then this part will become 0. So we have only one solution. In this problem, we want to use quadratic formula to solve for x. The given quadratic equation is 6x squared plus 6x plus 1. A equals 6 and b equals 6 and c equals 1. The formula was minus b plus or minus square root of b squared minus 4ac over 2a. All we have to do is substitution. B is 6, so we have minus 6 plus or minus square root of b is 6 squared minus 4 times a is 6 and c equals 1 over 2 times a is 6. So that equals minus 6 plus or minus square root of 36 minus 24 over 2 times 6. 36 minus 24 equals 12. 12 is 3 times 4. So we can rewrite it as minus 6 plus or minus square root of 3 times square root of 4 over 2 times 6. That can be written as minus 6 plus or minus 2 square root of 3 over 2 times 6. Here, 6 is 2 times 3. So the numerator can be decomposed into 2 times minus 3 plus or minus square root of 3 over 2 times 6. Then these two will cancel each other. And then we have minus 3 plus or minus square root of 3 over 6. So there are two solutions. One is minus 3 plus square root of 3 over 6. The other is minus 3 minus square root of 3 over 6. In the next problem, we want to use the quadratic formula to solve for x. The given one is 8x squared minus x minus 3 equals 0. They are asking you to round your answer to the nearest hundredth. So you have to use calculator. In the previous example, there is no instruction. In that case, they are asking you the accurate answer. That means you should not use calculator. Let me write down again minus b plus minus square root of b squared minus 4ac over 2a. So x equals minus b means minus 1 plus or minus square root of b squared is minus 1 squared minus 4 times a is 8 times c is minus 3 over 2 times a. So that is 1 plus or minus square root of 1 plus 96. So over 16. So that becomes 1 plus or minus square root of 97 over 16. Then you have to use calculator. There are two numbers, 1 plus square root of 97 over 16, and the other one is 1 minus square root of 97 over 16. The first one, when you use your calculator, it must give 0.68. For second one, you must get minus 0.55. In the next example, we have to find all complex solutions of the quadratic equation 5x squared plus 5x plus 3 equals 0. Here a equals 5 and b equals 5 and c equals 3. So the solution is minus b, which is minus 5, plus or minus square root of b squared, which is 5 squared, minus 4 times a is 5, times c is 3, over 2 times a is 5. So that is minus 5 plus or minus square root of minus 35 over 10. Minus 35 must be rewritten as I times square root of 35. So we have two solutions. Those are minus 5 plus square root of 35I over 10 and minus 5 minus square root of 35I over 10. In the next problem, we have to compute the value of discriminant and give the number of real solutions of the quadratic equation. Let me remind you the quadratic formula again. That is minus b plus or minus square root of b squared minus 4ac over 2a. And in this problem, we have to calculate the discriminant and the number of real solutions. What we learned at the beginning is when b squared minus 4ac is greater than 0, then there are two solutions. And if b squared minus 4ac equals 0, then this part will vanish. So there is only one solution, which is minus b over 2a. Here, a equals 4, and b equals 5, and c equals 4. So x is minus 5 plus or minus square root of b squared, which is 25, minus 4 times a times c. So when you calc over 2 times a, when you calculate it, that'll give you minus 5 plus or minus square root of minus 39 over 8. So the discriminant is the number under the square root, which is negative 39. And in this case, number of real solutions is 0, because this part will be rewritten as I times square root of 39. If the discriminant is strictly greater than 0, then there are two solutions. If that becomes 0, then there is only one solution. But in this problem, the discriminant turned out to be less than 0. In that case, that is a complex number. As we could see here, so number of real solution is 0.